So let's take a look at an example. In this first example, we have looking at flights, and we're looking at flights comparing them between 1 day advance and 30 days in advance, and how much they cost. Well, and they tell us the significance level. Let's see, we've got a 0.01 significance level, so let's go ahead and write that down. 0.01 significance level. So automatically we're looking at two lists of data. We've got a list 1 and a list 2. And we want to see if it's effective in saving money. Well, the way they actually listed out the original claim was actually a little bit nicer. Let's read that. The claim that flight scheduled 1 day in advance costs more than flight scheduled 30 days in advance. So let's write that out. The claim is that the mean for 1 day in advance, that's our first list, it is going to cost us more than the 30 days advance, which is the second list here, so more than 30 days in advance. Now, when we just talked about this, we don't want to leave it like this. This leaves us with two different lists to deal with at once. We'd rather write these on the same side and deal with their difference. So to do that, we're going to treat it like a regular equation or inequality. We'll get them on the same side by subtracting the mean of the second group over to the other side. And then what we'll do is, then we've got the first minus the second. We're just going to call that the difference. And we can leave our greater than the way it is. Now, on the other side, what do we have? We took whatever we had there and we moved it to the other side. So now we just have a 0. So instead of dealing with two groups, now we've looked at taking their difference. That's that mu1 minus mu2, the difference. And remember, that's going to be my special list that I'm going to put that in as my list 3. So my claim is that the difference is greater than 0. Now, because my claim has a greater than, not a greater than or equal to, it will fall in as my alternative hypothesis. So I can go ahead and put that mu, the mean for the difference, as my alternative hypothesis. That means my null hypothesis is the opposite, less than or equal to. Then what do? I can go into my calculator and go into my stats key and do my edit, and I need to put all of my first list for the 1 day data, that was my first list, into L1. And then I need to take all of my 30-day data and plug it into my L2. But again, that is not what I want to do my t-test on. I want to do it on their difference. Remember, the D was for difference. So you have to go back to your main screen on your calculator and do your L1 minus L2. Remember the little arrow here is that STA key, the store key, and store it into L3, and then press enter. Notice when you press enter, it will actually find you the list of all the values subtracted from L1 and L2. If you were to go into edit and go back into your lists, what you would notice right here is L3 would now have a bunch of numbers. That is your L1 minus L2, and they went ahead and put it in L3. I would go ahead and make sure that your L3 has the numbers you expected in there, which should be all of these numbers that are listed here. Then continue. Now you don't care about the first list or the second list. We're only going to deal with the third list, the difference. This is our difference list. Which means I'm down to one list of data that I actually care about. So because I'm down to one list, I'm just going to do a regular t-test on that list. So I can do a regular t-test here on just list 3. Be careful. That is not the default. List 3 is not the default. Usually it defaults to list 1 if you've done any testing in your calculator semi-recently. Also, this means if you go to study for your final exam, and you do problems from a previous chapter, you may need to go change this back to list 1 if you're doing stuff from a previous chapter. So be careful. The mu naught here, the reason why it's 0 is, remember, we were looking at a mu d being greater than 0. That was our h1. And our h naught was that mu d was less than or equal to 0. Either way, remember the mu naught here comes from whatever's on the other side on your null hypothesis and your alternative hypothesis. And in this case, it's always going to be a 0. Let's see, continuing along, the frequency, we always leave that as 1. Now, we have a greater than in our alternative. That's why we're using a greater than here, to make sure it does a right-tailed test. You'll have your calculator go ahead and select down all the way towards the bottom to have it calculate here. Have it calculate. And remember, just like before, it should spit out 2 pieces of information, a T and a P. Now it got cut off here, so you can't really see it, but it spit out a p-value of, if you run your test, of p equals 0.0016. So let's go ahead and use that. Is your p-value less than or equal to alpha? Remember, that question doesn't change. So is p less than or equal to alpha? Well, the p from this problem is 0.016. That's what was given to us from the calculator by running the t-test. What about our alpha? Our alpha is given in the problem. Our alpha was, let's see, if you go back to the original problem, 0.01. Well, let's see, is 0.0016 less than or equal to 0.01? It certainly is, yes. What does yes mean? Yes means that we will reject H naught. So I need to restate my H naught and my H1 to figure out what that means. Well, go back and look at it. Remember, H1 was that your difference was, let's see, greater than 0, and that was our claim. And our null hypothesis was that the difference, the mean of the difference, was less than or equal to 0. Now, we just said that we are doing what? We are rejecting H naught. So we're not failing to do something, we're actually doing something. We're rejecting H naught, although that's not what I care about. I care about the H1, the claim. So if we're rejecting H naught, we're going to accept H1. We're going to do the opposite. We'll accept H1. Well, notice we're actually doing something. We're not failing to do something. So we're going to say that there is, let's see, sufficient evidence to do what? We're going to say that there is sufficient evidence to, we're not rejecting, our claim is down below, so there's sufficient evidence to accept the claim. What was our claim? Our claim was that if you're scheduling 1 day in advance, costs more than scheduling it 30 days in advance. Now, we just did the p-values approach, but you could do rejection regions. Remember, if you're using rejection regions, that what you have to do is you have to take your alpha and put that as the area in your tail, or tails if it's two-tailed. Then you'd have to use your inverse t function in your calculator or the t distribution table to work backwards to find the rejection region. Then you would create your rejection region, and instead of using the p-value that your calculator spit out, you would use the t-value from the calculator. That would be your test statistic, and you would see where it would fall. If it fell inside the rejection region, you would reject. If it fell outside the rejection region, you would fail to reject. Really, the issue of doing these problems is, like I said last time, is finding the degrees of freedom in order to use your t-table. That is not easy. So that's why we're not bothering with this, but it is possible.